Hello, everyone. I hope everyone's doing well today, and I have another video here for you guys. Another pretty active day across the Ohio Valley expected. More of a damaging wind threat, some isolated tornado threat, but mostly going to be along the eastern side of Wisconsin, Chicago, Chicagoland region, and then maybe even far um, West Michigan here. But that is pretty low, but it's going to be mostly a damaging wind threat, maybe some hail as well. Um, but this is the current radar. This is sort of what we're going to be working with today as this moves southeastward into the Ohio Valley. This is what's going to cause our severe weather. So um, let's look at that real quick at our outlook here. This is our convective outlook for today. Day one. Um, we have an enhanced risk mainly across sort of your upper Ohio Valley into sort of the upper Midwest, Great Lake region, lower Great Lake region, Milwaukee, Chicago, Fort Wayne, Indianapolis, Toledo. Um, may as well throw in Detroit in there. Dayton, may as well throw Dayton in there. So all in this sort of enhanced risk, with this slight risk sort of surrounding it. All of Michigan, all of Ohio, um, your western part of West Virginia, much of Kentucky, but central northern Kentucky in particular, um, much of Illinois as well. But like I said, it's going to be mostly a windbag event. Here's your tornado risk. I think mostly your tornado risk is going to be, you know, kind of up in this pink area, in my opinion. Maybe as this, there's a lot more uncertainty of with how this convection up here, how it plays out sort of into this region tonight, and I'll sort of go over that briefly. Um, but yeah, here's our tornado risk. But here's what I was mentioning: our um, damaging wind risk, and we do have a sig one hatch over sort of much of the slight risk and all of the enhanced or of the yeah, excuse me, the enhanced risk here. So or the 30%, I should say. Um, and then the slight risk also sort of goes into the Ohio Valley region of Huntington, sort of Pittsburgh, Louisville. But like I said, there's a bit more uncertainty in these regions, and sort of in these regions here. Horrible circle, but or not even a circle, but you know what I mean. Horrible drawing. Um, that's besides the point. And then our hail threat, gonna be mainly concentrated across the Chicago region, Milwaukee, and then potentially into sort of northern Indiana as well. So back to the radar here. I did see a tornado warning here. Um, I don't want to draw, but I did see tornado warning already. So it's already a pretty active day. Radar indicated. Nice sort of signature there. Look at our velocity. Nothing sort of crazy. Not a crazy signature there, but we definitely do have some broad rotation in there. Um, enough to sort of warrant that tornado warning. Yeah. It's already an active day across parts of Wisconsin, and then sort of going to be an active day for Chicago, South Bend, to Grand Rapids. So just be on the lookout for severe weather. Even have a destructive severe thunderstorm warning, 3-inch hail. That is crazy. Um, just north of Appleton, Wisconsin. But let's look at the risk further into the Ohio Valley. That's the current radar right now. Not too bad. Look at our current satellite. Um, I mean, yeah, we have plenty. I mean, we have some cloud cover across, you know, sort of central northwestern Ohio, but lots of clear skies, especially across central Indiana, Illinois, especially across central Kentucky, and even parts of the tri-state region across West Virginia, Kentucky, Ohio. But yeah, I mean, we have enough clearing. we're gonna have enough instability, enough heating for today. That's not gonna be an issue. But yeah, satellite was looking good. Again, radar. Most of your convection is going to be up into the Great Lakes near Chicago right now. So yeah, let's look at some models, and we're going to look at why this setup has a lot of sort of uncertainty because a lot of models have different things. So um, yeah, so first off, this is the HRRR. This is the 12Z run. I might just switch over to the 14Z run, but it's not doing much better. Again, if we switch over to radar here, um, it doesn't even have this convection across sort of southeastern Wisconsin, northeastern Illinois. So it's really it has maybe a little, obviously there in Chicagoland, but some in central Michigan, but it's not doing well. And then our main sort of line is a little further north, um, but yeah, the latest HRRR by this evening here, our time and date right here. By this evening, um, according to this model, sort of central Indiana, northwestern Ohio, under the gun, and then into sort of the Cincinnati, Huntington, maybe Indianapolis, Lexington region by midnight, 3 a.m. So it's possible. Again, greatest uncertainty is going to be sort of, I think, in this sort of region here. Um, and I can just go ahead and sort of show that now. So this is again our 14Z HRR one, so our 9 a.m. run. So if we switch it back over to our main 7 a.m. run, our main morning run, look how different it is. Look how it has this well-defined sort of boa, or not really boa, but just well-defined sort of mesoscale convective system with this bow feature here. Um, and if this were to be true, there would be pretty intense winds in this sort of section here. But again, this is the 7 a.m. run to the 9 a.m. run, and we can already see a difference of sort of a less organized um, structure across here, but still producing severe weather. So I definitely think across central Ohio, far northern Kentucky, across much of Indiana, you're gonna have that's your greatest confidence of severe weather this evening into tonight. Once we get into sort of central Kentucky, um, you know, eastern Ohio up through Pittsburgh, and most of West Virginia, the coal fields, again, parts of central Kentucky, your confidence is going to be a lot lower because we don't really know how this is going to set up, this convection across um, Wisconsin and Illinois. We don't know how this is going to sort of evolve. And and a reason we know that already is because look at the difference. Again, latest triple R run, 12 p.m. We don't even have a lot of this convection up through here. So it's just it's kind of frustrating in a forecasting standpoint, but we have to just take what we have and sort of go with it. But also, this is just one model run. So let's sort of look at um, different aspects of this model first, but then we'll also look at maybe another model run or two to see what that's saying. So I'm going to switch over to the 12Z. Let's sort of look at why this is so, or why this sort of pattern is happening, and why this northern pattern is happening of where our convection is coming from the north, and it's all thanks to this, um, high pressure across the plains here, um, and this is setting up a ridge. So a ridge is sort of like a rainbow, kind of like where our flow goes like this. I've mentioned this before, but our ridge, we're gonna have most our flow on a ridge on the top side of our ridge, and then our trough here, um, where it's like a U, our ridge, it sort of looks like a rainbow, and then a trough is like the letter U. So as it goes into the letter U here, or the trough, we can see the base of the trough is where the flow ends up. So our low pressure would be somewhere sort of up through here, um, but some type of low pressure would probably likely be up through here. But that's besides the point. Um, this is sort of how the flow works here. So when we have this ridge here, it brings energy and this wind energy from sort of the Pacific Northwest, and then also into potentially in parts of Canada. And we can see this if I switch model runs here, just clear all this here. We can see this. It's taking taking this energy here from this trough across sort of the Pacific Northwest um, of the Pacific Ocean here, and it's sort of feeding into this ridge, right? It's feeding into the top of the ridge, feeding it with some energy, feeding it with um, the wind energy, and it's bringing it across the Great Lakes, bringing it into the Ohio Valley. This is why we have sort of these convective systems and all these storms coming from the north the last few weeks. So we've had this pattern set up um, most of the summer. I want to say since probably early to mid June. Especially I see definitely mid to late June. Definitely maybe not as early June, but um, anyways, we have this northwesterly flow at our 500 millibar level, and this is around 6 kilometers up in the air. Super important to sort of help keep sort of thunderstorms alive, keeping their updrafts alive, keeping sort of that wind energy up there needed for these thunderstorms. So this was the Euro model, just to sort of show you um, the extra energy, the extra sort of wind energy it's picking up from another low, um, across sort of south of Alaska and sort of the Pacific Northwest of the Pacific Ocean. So, um, it's all a complex sort of system at the end of the day. So back to our HRRR model. I'm going to clear our drawings, our horrible drawings, and again, we're back at the 500 millibar wind map here. And so throughout the day, so most of our convection um, sort of across right here. So out ahead of this convection, we already have plentiful wind energy at our 500 millibar levels of around 30 to 50 knots. Maybe not up to 50, but definitely around 30 to sort of 45 knots across sort of in Indiana, especially sort of northwestern Ohio. But as we progress through the day and the afternoon, this wind energy continues to work its way from the northwest. This northwesterly flow keeps pushing in, and it's still around this 30, 45 knot range. And by then, oh, excuse me. Um, and by then, most of our convection by 8 p.m. is located across sort of potentially Chicago, Detroit, Cleveland. Um, so yeah, so if we continue sort of after this, wind energy continues to be plentiful across the Ohio Valley, even into the overnight hours, into Kentucky, West Virginia. So it's that's interesting to note. Let's look at our 850 millibar. This is sort of closer to your surface. Um, Again, into the afternoon, evening by 8 p.m., 9 p.m., most of your storms are across Chicago, Detroit. Out ahead of it, we do have sort of that southwesterly, sort of westerly flow out ahead of it, bringing in sort of rich moisture, um, vecting that rich moisture out ahead of the sort of mesoscale convective system. And this will continue into the overnight hours and sort of ramp up as that low level jet begins to ramp up as it sort of always does. Um, but yeah, this is pretty impressive for a low level jet. This is around midnight tonight, and this is going to be an overnight event most likely across some portions of the Ohio Valley. But yeah, we have easily 20 to sort of 40 knot winds across this region. So wind energy is I would say significant, and a good way to sort of look at that is our shear value of 0 to 6 kilometers, and sort of just takes from the surface to 6 kilometers up the atmosphere, takes an average of the shear values, um, and sort of prints them out as a bulk value here. Again, and this is really nice to sort of look at in these sort of type of systems where we have potential damaging winds. So throughout the afternoon, we have our bulk shear values of, it may not look impressive, you barely have these sort of blues, but if we go over here, on our legend onto the right side, 20 knots is barely even a blue. And if we get into the light blue, that's 30, and then sort of a darker blue, that's 40 knots. So we have easily 20 to 35 knot, 0 to 6 kilometer shear. As we move on throughout the evening, this sort of ramps up out ahead of the main line. Our main line is sort of Columbus, Indianapolis at this sort of point, potentially. Um, and then out ahead, again, we just have 20 to sort of 35 knot. So a good signal for sufficient wind energy to sort of support any type of convective system that begins to form once it passed sort of Chicago and Detroit. That's really the main key for today, especially across Cincinnati, Columbus, Louisville, Huntington, Parkersburg, Pittsburgh. How does this convection across Milwaukee, Chicago, Appleton right now, how does this sort of evolve as it moves southeastward across Fort Wayne, Detroit, Chicago? If it looks like sort of your um, bowing like this, then we may have an issue with damaging winds. But if it looks sort of more unorganized, like our latest 14Z, um, some people are still going to get severe weather, but it may not be as spatially um, significant as maybe this model run here, the 14Z. But this just goes to show how uncertain today is with the severe risk, and just how um, obviously prepare and sort of you know, take these forecasts serious, but also just sort of know that it's more of a toss-up event for today. So let's look at our surface-based CAPE here, and this is sort of our surface-based energy. This is what's going to be very important to get these storms going and to support sort of your initial development. So 1 p.m. here, so 12 p.m. Eastern right now. So this is about an hour already ahead of time, and we can see across sort of your lower Ohio Valley region, Mid Ohio Valley region, we don't have much, but across Indiana, Ohio, southern Michigan, much of Illinois, we have over 1,000 joules per kilogram, and that's going to be more. You want over 1,000, but you want over 2,000 and be more than enough. And we do have a nice sort of swath of 2,000 across central Indiana, sort of across much of Illinois as well. But as this sort of moves on throughout the day, this is going to be, again, remember those westerly winds. Remember in the 850 millibar, those westerly winds sort of were like this. Look how that cape's moving. It's sort of moving like how those 850 millibar winds were moving, and that's because this is surface-based cape, and 850 millibars is going to be closer to the surface, around believe 1 kilometer. So that's why that cape is moving sort of more to the east, while this cape is moving more sort of southeast. But yeah, it appears here to this, the 14Z here, HRRR model. It appears that a lot of the cape is going to be sort of centered is situated across, excuse me, across central Indiana, sort of southern Ohio, much of Kentucky, and then much of sort of central southern Illinois. And again, I think this is your greatest, especially across Indianapolis, Fort Wayne, maybe even Columbus, especially sort of um, west of Columbus, maybe Dayton. You're gonna have your greater confidence, maybe not great confidence, but overall, but you're gonna have your greater chance of having severe weather. But if we compare this to our 12Z, sort of shows that same thing. Um, and then across sort of your Huntington Charleston area, you only have about sort of 750 to 1,000, barely 1,000, but around 750. So your greatest instability, your storm field is going to be sort of centered across your central Ohio Valley region here. Um, and you can see that sort of evolve like that. And let's look at our mixed layer cape. And this is around sort of, this is going to take, um, this is going to take sort of your mid-atmospheric instability. And this is important to sort of keep your longevity of severe weather and storms, to sort of keep the storms fueled um, more than just in the surface, but you need it also you need a fueling source in the mid atmosphere to sort of really keep the storm going and to have enough fuel for it to keep going. So, um, this is our mixed layer cape. This is our mid atmosphere. Again, HRRR 12Z, 2 p.m. And we have significant mixed layer cape across Chicago, Milwaukee, Appleton, Wisconsin. And as this progresses throughout the afternoon, we have again, in evening, we have significant mixed air cape of around 2,000 to 3,000 joules per kilogram across much of Indiana, much of central western Ohio, much of central and western Kentucky. And I think this is going to be your greatest area of severe weather. Sort of in this area here, Columbus, Cincinnati, Louisville, Indianapolis. This is my opinion, greatest sort of um, region for that longevity of that sort of convective system to keep moving southward overnight. Um, and we can see even across 2 or 3 a.m., we still have 1,000 to 2,000, joules per kilogram mixed air cape. So we have, plenty of instability, plenty of wind energy to keep any type of sort of organization of convection that we have up here going. So we have plenty of energy for this to keep moving southeast. So let's look at another model. This is the NAM here. Again, it's doing maybe a little better with sort of potential convection across northern Illinois, parts of Wisconsin. It's doing decent up through here. Not great though. Um, Same sort of issues where it's just not confident in the placement. So as this continues throughout the afternoon, it's just sort of a messy look here. The NAM doesn't have this sort of organized look like the HRRR did. But as we move on throughout the evening, we do have maybe some type of organization of some type of mesoscale convective system across Indiana, maybe parts of northeastern Illinois. This is 9 p.m. This evening, so as this moves on, we have maybe Louisville, Lexington, Evansville, Indiana, maybe, and then it shows maybe some potential convection popping up across Columbus, Huntington, Parkersburg, but take it with a grain of salt. This is a pretty messy look. Let's just look real quick at the upper air map, see how it looks compared to the HRRR. Um, Relatively the same. You have that northwesterly flow. Maybe the NAM is a little more significant with the wind speeds here at our 500 millibar level. Definitely maybe some pockets of 50 to 60 knot winds at our 500 millibar level. It's like our 850 millibar level closer to the surface. Remember, we're going to have more of these sort of westerly winds, sort of funneling in, helping bring in that cape, that instability, and that moisture advecting in front of the convection. So shows that sort of same setup, and then by overnight, that low level jet really kicks in across the high valley, sort of Kentucky. So um, definitely, raises an eyebrow of potentially an overnight wind threat too. So this, it could be a busy day across the high valley. So definitely um, you know, keep weather aware today. Have a way to get warnings as well, and all that other good stuff. So the NAM also, it overdoes its, I hate the NAM bias, the NAM 3K bias here. It always has a bias with its cape and its instability. And we can see this, like values of like 5,000 across Illinois. And this sort of last overnight into central Indiana, into even Cincinnati, Louisville, 3,000 plus. Um, but it has a lot of a lot of that instability and moisture. So again, NAM shows a favorable setup ahead of this convection stills, and I think that's what matters in these sort of setups. When these model runs are giving us different sort of outputs every time, it's more of looking at these parameters than anything else at that point. And obviously, you need to do that anyways when you're looking at models, but um, there's a lot more that goes into it than sort of looking at just your radar output here. Um, but anyways, yeah. Today has potential to be a pretty active day. It already looks to be pretty active across Milwaukee, north of Chicago, and that's going to be moving into Chicago really soon. Um, so yeah, just be weather aware today across the Ohio Valley. It's already, like I said, already an active day. The main thing, as I've mentioned, is watching how this convection up here, how this moves southeast, and how it sort of evolves in this region here. Um, what's gonna happen? I don't know. We'll see. We'll see. It's just one of those things where now casting, sort of looking at real time observations and looking at the data coming in each hour on like the meso analysis. It's gonna be one of those sort of days. So just stay weather aware. It's gonna be hot. It's gonna be humid. Regardless, I think our highs are gonna be in the 90s. We can look at that real quick. I'm gonna use Euro Ensemble here to get our mean. So yeah, I mean we're gonna have mid 80s across much of the Ohio Valley, even maybe some low 90s involved. And look at our dew points. Yeah, we're gonna have a juiced up atmosphere, especially across sort of Indiana into sort of central western Ohio and then sort of central western Kentucky. Plenty of moisture available for any type of convection. But that'll do it for today. Kind of a longer video, longer than I sort of wanted to be, but a lot of uncertainty to sort of unpack and a lot to go over. So I hope this helps, and I hope you'll stay safe. And this sort of severe threats, I should say, real quick, the severe threat does move into sort of the mid-Atlantic region, into sort of the um, the Carolinas, into the mountains here. So depending on how this looks in the morning, also may make a video on how this will sort of play out as well. But yeah, I will catch you guys later, and I hope you guys have a nice day, and again, stay weather aware today.